Okay, we have been talking about the equation of a circle, and the standard form for the equation of a circle, as we know, is x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. So in this situation, we have x minus 2 squared plus y minus 3 squared equals 25. The center would be at 2 comma 3, and the radius would be 5. But what if the equation is in a form that looks like this? Where would the center be and what would the radius be? We have to change an equation like this into an equation like this. And to do that, we need to do a process called completing the square. Completing the square, you need to add the smart amount to both sides of the equation to get the x and y trinomials into perfect square trinomials so that the factor into the binomials is being squared. Let's go through that process now. So first of all, what is a perfect square number? Let's take a look. Numbers such as 1, 4, 9, 16, 25, 36, etc. are perfect square numbers because they are all numbers that are a number times itself multiplying into them. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc. So what is a perfect square trinomial? Well, here we have a trinomial x squared plus 2x plus 1. It's a perfect square trinomial because it's x plus 1, the quantity squared. Here's the second example. X squared plus 4x plus 4 is a perfect square trinomial because it's x plus 2, the quantity squared. And a third one, and a fourth one, and a fifth one. Now what do we see some patterns happening here? Here's a sixth one. Can you come up with the seventh one? Look for a pattern. Here are some more perfect square trinomials. X squared minus 2x plus 1, x squared minus 4x plus 4, x squared minus 6x plus 9, etc., etc. Can you tell me what this next one would be? So to get a perfect square trinomial, we say that x squared plus bx plus c when factored is factored from x minus k, the quantity squared. That is, a trinomial is factored to a binomial being squared. So what are the properties of a perfect square trinomial? Take half the b term and square it. That number belongs in the c spot. In your workbook, you'll have some examples like this. See if you can fill in these blanks. Now try problems 6 and 7. Let's take a look at our answers. Here are the answers for the first 5. And here are the answers for problems 6 and 7. Let's take a look at the example that we saw earlier, something like this. We want to find out where the center and radius is for an equation just like this. So here's the problem. First thing we want to do is separate the x's and the y's such a way that we have x squared plus 6x plus some number equals y squared plus 14y plus some number. We're moving this negative 6 to the other side. And whatever we fill in here has to be filled in on the other side as well in order to keep our equation balanced. The smart number is to divide 6 by 2 and then square the result. In this case, 9. Divide 14 by 2 and square the result gives you 49. So 9 completes the square on this side. 49 completes the square on this side. Of course, we have to add 9 and 49 to the other side as well. And so now we know that x plus 3, the quantity squared, is this trinomial, and y plus 7, the quantity squared, is this trinomial. And if we add 6, 9, and 49 together, we get 64. So the center is at -3, -7, and the radius length is 8. Let's go back to our worksheet now and try one ourselves. So let's go ahead and try this problem right here. Okay, so let's taking a look at problem number 10. We know that we could separate x squared plus 8x plus something equals y squared minus 6y plus something. We're going to fill in these blanks on both sides. The number that completes the square is 16. The number that completes the square here is 9. So we have to add 16 and 9 to both sides. This is now a perfect square trinomial. So it's x plus 4 squared. This is a perfect square trinomial. So it's y minus 3 squared equals 5. So now we know that the center is at negative 4 comma 3 and the radius is the square root of 5. Let's try one from the next page. Okay. Try this one. Okay, let's see how you did. It helps to keep these numbers that are the smart amounts in fractions. And one more. Let's try this one. And here are your answers. So, completing the square again allows us to get equations in the general form for a circle. All right, good luck.